Okay, so I'm going to walk you through the assignment for measurement conversions between systems. So that means you are going from metric to US customary and back and forth, okay? So the setup is a little bit different. Ish. Okay. So this one says a sign shows that the distance to New York is 18 miles. A traveler wants to know, what's this distance in kilometers? Okay, so we're just going from miles to kilometers. In case you don't remember, miles is something that we use in the US. Kilometers is in the metric system, right? Meters, kilometers. So we're going from US customary to metric. Help the traveler by completing the parts below. So basically, this looks super complicated, but all this is kind of like it's kind of like a problem with a word bank, right? These are your options right here. You can use an X, a 1, 1.6, or 18 to fill in these spots, okay? And if you have watched my US customary video, which you're supposed to, you've seen how to fill this out and how to work it out already. And it's the exact same format as our is over of that we've been doing for percent. So it shouldn't scare you. It just looks complicated because they have it set up for you and then they have your options, okay? So this says let X be the unknown number in kilometers. So X is what you're looking for. We always use X for what we were trying to find in our percent problems, right? So that's nothing new. Using the values below, create a proportion that can be used to find X. So the proportion down below is just to help us find the answer. Use the conversion. 1 mile equals 1.6 kilometers. So if you remember, we always started with, okay, what is our conversion rate? We're going to put that in our first rate right here. Okay, so our conversion rate is 1 mile. We're going to put a 1 here, right? And then we are going to put 1.6, or 1 and 6 tenths kilometers are on the bottom, right? And then what are we trying to find? We're saying, okay, New York is 18 miles away. How far is it in kilometers? So my X has to go on the bottom because my X represents kilometers and so does the 1.6, right? Kilometers, right? And then in our conversion, the 1 was miles. And now my 18 is also my miles. So the 18 goes on top. So that's all you're doing. It's essentially what we did before. You just happen to be writing it all out. Okay. So we're setting up what we found in our conversion chart. We're setting up what we're looking for in our problem. And then it says use a proportion from part A to find the distance. Okay, so basically it's just saying, hey, part B is, solve it. And then don't round anything. Okay, so again, I'm going to go through and solve it with you. Okay, so if I cross multiply here, 1 times x is the same thing as 1x, right? So the only thing that I have left to solve is right here. And the fabulous thing is they are giving you a calculator, right? So I can go through and I can say 1.6 times 18, right? So my answer is 28 and 8 tenths of a kilometer. 28 and 8 tenths of a kilometer. Okay, that's what the cross multiplication would be. All right. I'm just going to finish this out so it doesn't look all derpy, but that's exactly what we had been doing in prior problems, correct? So that should not throw you off. All right, I'm trying to move this. Ta-da! Okay. So again, you're just conversion chart, what the problem's asking you, and then cross multiply. Okay, let's try another one. Whee! Okay. Hans filled up his boat with 123 and 5 tenths liters of fuel. Okay, so we're talking about liters, meters, liters, grams, that's all metric. Okay, so liters. We're in the metric. He wants to know this amount of fuel in gallons. So he's trying to convert it to a US customary. We talk about gallons of gas, right? So help Hans by completing the parts below. Let X be the unknown of gallons. So X is what we're looking for. Always is. Use the values below. Like this is kind of like your word bank, your number bank, right? Use these below to create a proportion. Okay. The conversion is 1 gallon is equal to 3.8 liters or 3 and 8 tenths of a liter. Okay. So again, Very first thing I always say, your first rate that you're filling out is your conversion. So I'm going to put a 1 for 1 gallon and 3.8 for 3 and 8/10 liters. Okay, so I have gallons on top, liters on bottom. Okay, so now if I go back up to my actual problem, that's what I'm going to fill in for the second part. I have 123 and 5/10 liters. Well, which number represented liters again? Oh, the 3.8. So that means my liters is on the bottom. So I have to write 123.5 liters on the bottom because I have to keep liters on the same level, like if they're on the top or on the bottom. And then I'm going to have to keep gallons on the other level. Okay, so the top, the 1, represents gallons. And in our problem, that's what the X is. We're trying to figure out gallons, right? Okay, so now we have it set up. This is my conversion information. This is from my problem. Okay, we knew the gallons, we knew the liters, and we're looking for the gallons. Okay, now we are ready to solve, right? Part 2 is just like, hey, use that proportion to find it. So let's cross multiply. I always start with my variable. So now I have 3.8 or 3 and 8/10 times x, right? So that's just pushing them together. And then multiply the other direction, cross multiply this way, and you get 123 and 5/10, right? Well, remember, it's an equation. So whatever you do to one side, you have to do the other. My whole goal is I want it to say X is equal to so many gallons, right? I'm trying to find the answer. So how do I get rid of this 3 and 8/10? Well, in algebra, you're always trying to isolate your variable, right? It's all by itself. It's isolated. Well, in order to get it isolated, I need to undo this operation, right? Right now I'm multiplying 3.8 times X. Well, to do the opposite, I'm going to divide by 3.8. So the opposite of multiplying by 3.8 is to divide. And whatever you do to one side of your equation, you have to do to the other, right? Nothing new. 3.8 over 3.8 is the same thing as 1, right? 1 whole. 1x or 1x. So that's why it ends up being isolated, because you turn this into a 1, okay? So now I have 123 and 5/10 divided by 3.8. And if that totally freaks you out, it's completely okay, because you can use a calculator for all of this. I'm reading it like a book from the top down. So whatever I read first is what I type in my calculator first. The 123 and 5/10 is what I'm chopping up. Okay. I'm dividing that into 3.8 pieces. Okay. Or sections. It's not pieces, since it's, a liquid, but whatever. Okay, so I got 32.5 or 32 and 5/10. Okay, 32 and 5/10 is my answer. And remember, that's gallons, because that's what we were trying to figure out from the beginning, right? So 32 and 5/10 gallons. Okay, so again, you fill in your proportion or your conversion rate, fill in what they're asking you, and then you solve it. Let's do one more together, okay? Next round. All right, again, so the very first thing I'm doing is I need to fill out a conversion rate and then what I am trying to solve in my problem. So let's go up here and read. A sign on a statue says the height of that statue is 115 and a half feet, or 0.5 feet, right? A tourist wants to know the height of the statue in meters. Okay, so we are starting with US customary feet, and we're trying to convert it to what the rest of the world use and what scientists use in meters. Okay, so help this tourist find this out. So let X be the unknown. Well, what are we trying to figure out? We're trying to figure out meters. Okay, that's why the problem at the bottom is like, how many meters? That's what we need to find out. So let X be the unknown of meters, and then use the values given, right, to fill in your proportion. Your conversion, which, remember, that's the very first rate that you're setting up here, is your conversion. So my conversion is 1 meter equals 3.3 feet. So I'm going to do 1 meter equals 3.3 feet. So that means meters is on top for me and feet is on bottom. So when I go back up to my problem, because that's what my second part is of my proportion, the number given to me, 115 and a half feet, feet is on bottom, right? Because that's where I put my 3.3. So that's where I have to put 115 and a half feet, okay? And I'm trying to find the meters, and meters is top. So that's where my X goes, all right? Now I'm just ready to solve, okay? So I'm going to cross multiply. I always start with my variable. 3.3 times X is just 3.3X, right? And if I cross multiply the other way, I get 115 and a half, right? 0.5 or 5/10. Okay. So now again, it is an equation. So whatever I do to one side, I'm going to have to do the other, right? It is time to isolate this variable. I want to get the variable all by itself so I can find the answer of meters, right? How do I undo this operation or the inverse operation? Okay, the opposite of multiplying by 3.3 is to divide by 3.3. Okay, that's because this becomes 1x or 1x, right? And whatever you do to one side, you have to do to the other. So I'm going to divide the other side by 3.3 as well. Okay, so again, don't freak out because you get a calculator, right? I'm reading it from the top down just like I would a book. So the first number I read is the first one in my calculator, right? 115 and a half, and I'm dividing that into 3.3 sections to get 35. So altogether, the statue is 35 meter sticks tall, okay? Ta-da! I really hope that that helps you. Just know that every single time, the very first thing that you're looking for, I'm going to go through and kind of like highlight this one more time just for you. You are paying attention to the conversion, right? Because whatever is written here as your conversion, that is your first proportion. That's the first side, okay? And then whatever number, whatever you're trying to find, right? That is what is going to go in your second part of your proportion, okay? So you have something that you know, and then you also have an unknown. So your unknown is going to be your X, right? Okay. And then you just cross multiply and solve like you normally would for our is over of as well, right? Okay. I hope this helps you guys.